Ronnie Dale, four-wheeling, westernaustralia.com, and welcome to a DIY 12 volt electrical tips and hints video. So this video is mainly going to be about the tools you need, how to use them, and some good little technical advice for all the little bits and pieces that you need to take on for doing a build like the one behind me, or any little temporary box or whatever. So this video is aimed for those who don't have much experience with 12 volt stuff, who would like to take on the job themselves. I'm not an auto sparky, I'm not a professional with electrics, far from it, but I have done 4 setups so far. So the advice I'm going to give you here is from what I've learned, and I have been getting good advice as well from the guys here at PDP, which is where I've done a lot of my DIY work. So I've been lucky enough to use their workshop and use a lot of their tools as well. So first up, we have all the tools that you will need to build your own DIY electrical custom canopy or whatever it is you want to do, even if you want to work on just general electrics on your vehicle. So to start off with, let's look at the general tools you'll need. So adjustable spanners, obviously, wire cutters, long nose pliers, screwdrivers. Then we go on to the specialty tools, wire strippers, crimpers, different kind of stripper and crimper in one, Stanley knife, industrial size crimpers. More on this later because you're probably not going to have this tool and you may not have to buy this, but we'll get onto that later on. Drill with a stepper hole driller, really useful. I'll get onto that later. Multimeter, if you don't have a multimeter, a test light will do. Crocodile crimps, crimped at both ends on a wire. That's one of my favourite tools. Then we're on to soldering irons. There's 2 different ones here. More on that when we get to soldering. A thermo little handgun for heat. Obviously some solder. And then we'll get on to all the components. Componentry. All the bits and pieces you need for your build. So the question that I used to ask a lot was wire. Now wire is quite confusing. What size do you need? There's a lot of charts out there, but unless you know how to look for it, it's pretty hard. So I'll save you the hassle. This is 3mm wire. This is a twin core wire. This is 4mm wire, and it is a figure 8 twin core. The figure 8 just means it's easier to split. It's like your speaker wire. It's easier to divide. So 3mm wire is good for anything that's 15 amps or less, which pretty much means any lights in your vehicle, pretty much everything inside your vehicle that you need to run power off. Now obviously not inverters and things, because they'll need a lot thicker battery cable. This 4mm stuff, you could actually run, well, I could actually use this to run my compressors off. Obviously 1 strand to each compressor. So this here is overkill for all your other stuff. Then we have battery terminal wire. So this kind of wire here is what you would run from the front batteries to the rear if you want anything under 90 amps. And of course, if you're going to run a parallel battery system, you need some even thicker cable. You need your proper battery cable, the stuff you'd run down to a winch or something like that. That's the real thick stuff, and it's very expensive. Then we have crimps, little crimps. Now, this is what I'd recommend to use because it's a lot easier to work with. And your reds and your blues, they will fit on your 3mm wire. Look, you can probably just fit a blue on this 4mm, but I would go straight to the yellow stuff. These are the ones that take the heavier gauge wire. Now, obviously, when you get to your battery wire, you're going to need proper terminals, proper battery terminals, and they need to be soldered. There's a lot more work involved in them. And that is where this big boy comes in. It needs to be done proper. Now we have switches and your cigarette lighter plugs. So with these, you'll find that the spade crimps fit onto these. That's why it's so good to work with. straight on like that. Then we move to heat shrink. Heat shrink is very important. If you are joining wires by solder together, you should really put heat shrink on it. So once you've joined it, you put the heat shrink over, and what it does is once you put some heat on it, this will shrink down. And if you get the stuff with the glue in it, it's waterproof as well. It'll seal the connection and it'll help hold it. But more on that when I show you how to solder. Corrugated tubing. This stuff here is very important for any wires that are on the exterior of the vehicle. Then you need this kind of stuff here. Very important. And if there's any vibrations or anything like that, plus it also neatens up the job as well. So in the thick one, you can obviously fit a lot of cable. These small ones, they're for like your wires to your lights on the outside of your vehicle. So here we have some more components. Let's put these aside for now. Let's look at circuit breakers and fuses. Now they both do the same kind of thing. It's the same principle. They will stop any short that's happening, or if there's any overdrill. Now the difference between a circuit breaker and a fuse is a circuit breaker will just trip, and then all you have to do is push the button to get it going again. Now you can get auto circuit breakers, which I wouldn't recommend, because some of them every 5 seconds they will automatically try and switch back on, and then they'll trip again, which you don't really want if there's a problem. The fuses, these are a once use. So once they blow, it's blown, so you need to keep spare ones of these. And for whatever you do, you need to either have a circuit breaker or a fuse for every single thing that you install in your vehicle, from the power end, of course. So if you have a light, so say this is the wire, you got the power feed from here, and there's another 5 meters of wire going to your light. You will only need a fuse at the power end, because if anything happens from up here, it'll still melt the fuse back here. So it'll still cut it out. You don't need something at the other end. That said, however, if you have a big cable going to the back of your vehicle, to one of these Anderson plugs, and you have an Anderson plug to connect your trailer power to on your trailer, you'll need a fuse at the battery end and at the Anderson plug end at the back of your vehicle. And the same with the trailer. You'll need one on the other side of your Anderson plug to the trailer's battery, because if anything happens and it's connected, you're still going to have power going through to those cables. So you need those fused at both ends. When there's power at both ends, fuse both ends. With circuit breakers, you can get smaller ones and you can get big ones. Now, usually, well, what I've done in my setup is anything that's got big power going to it, I'll use a circuit breaker. Anything that's got small power going to it or small current going to, I'll use the fuses. 30, 25, 20, 15, 10, 7.5, 5. And then there's all different types of fuses as well. So keep that in mind. Get fuses that are easy to get your hands on. And the fuses that are not so easy to buy on the roadside, out in the outback or wherever you're going to be, make sure you carry spares of those fuses. Like these mini fuses. These are actually quite hard to get, but they're all over eBay, right? You're not really going to get a parcel delivered out in the middle of nowhere. This is a mini fuse holder. So this is for your bigger current sort of cable, which can go in here. You've got terminal lugs that can go in on either side. Commonly used for transferring power from the front to the back of your vehicle. Then back onto the Anderson plugs. Now these I would highly recommend for anything that's external on your vehicle, like your trailer plugs, just even your solar power. So say you have a solar blanket, you'll have one of these on the outside, and then you can connect your solar to it from wherever you're using it. Two other good items to use in your setup are these two terminal studs. You have your positive, which is red, and you have your negatives, or your earthing, which are black. Now, I'm not too much of a fan of using the positive studs unless you get a nice cap on them. I had a previous build where I didn't, and they're a bit exposed there. All you need is anything that's earthing to touch it, you could have an electrical fire. The grounding plugs, you can pretty much put anywhere. Now, when you're wiring anything to your vehicle, your positive you must get from your battery, obviously, but your grounding and your negative wire you can just take from your chassis. It doesn't need to come off the battery, although I would recommend pulling it off the battery and perhaps the chassis as well for your best connection. On to switches. with your switches, make sure that it has the correct amp rating for whatever you're running. So for lights, it's not really that much of a problem unless they're driving lights. If they're driving lights, you may need to use some relays. So you have a switch that can handle small current, you flick it on, it will then send a signal to your relay, and then your relay will then take on the heavy load and switch your driving lights on. So for example, your car will have them in there as well for your high beam, your low beam, but if you install extra lights, this is what you will need: relays for your spotties, your LED lights, all that kind of stuff. One other tip with relays. Now, most relays are just your standard relay. They do what you tell them to do, but you can get some relays that are volt sensitive, which means if you have a battery connected to it and it drops below a certain voltage, the relay will then cut the power. Or you can make it switch to another battery. Now I'll give you a quick tutorial on how to strip wires and how to crimp these lugs onto your wire. Wires, pretty simple when you've got a tool like this. This is why I recommend getting a tool like this as well. Otherwise you're going to have to stuff around with a Stanley knife. Stanley knife's still handy to have for your battery terminal wire. So, put it in like so. Easy peasy. And you have two wires exposed here now. And each wire like that simply again. The automatic stripper, really good. If you have one of these, all you need to do is find out which hole it slots into, like that. And then you clamp it, and then you basically twist around and pull off. There you go. Now just make sure that you don't pull any of these strands off, because then you are lessening the current that this wire can handle. So I have two wires here pre-stripped, two different sizes, just to give you an idea. So you have different types of crimps here. This one here is a bullet crimp, and then you have the terminal crimp for like your terminal lugs. And then you have the spades, which I recommend that you would use on most of your stuff. As I showed before, all the spades will go on the back of those cigarette lighter plugs and most of your switches. So obviously there are different sizes. Red are smaller, followed by blue, followed by yellow. It also goes with the wire size. So you will find that with the 3mm, the red and the blue should fit pretty well. When you get up to this size here, you need the yellow ones. Now with the yellow ones, you can even feed extra wires into one. And the benefit of putting more wires into one of these is so it eliminates the amount of these you have on your terminal pins. So you have less lugs on your terminal pins. Grab your wire, twist it whichever way you want to go, clockwise or anti-clockwise. Once you got it like this, you grab your little lug, spade lug, and you feed it on. Now you push it until the rubber hits the back of it. That means it's on proper. Then you grab your crimper. I tend to prefer to do it this way. And what I do then is I will get this in, I'll take the pressure on it, hold it there, and then simply squeeze, done. That's crimped, done. Okay, tools for soldering. I've got some solder here which has lead in it. It's just easier to use the one that has lead in it. Now you need to be in a well ventilated area obviously. Safety glasses, probably a good thing, and some kind of breathing apparatus. But I'm pretty well ventilated here. You don't want to be breathing in the fumes. I have two different types of soldering irons here. I have the gas powered, my preferred, and I brought this one from home. As you can see, it's quite dusty, so I haven't used it for a while because I prefer to use the gas solder. Another reason why I like to use the gas solder is you get used to using this particular tool, and this becomes part of my Overland kit. So this is always with me. So if anyone else has an electrical problem, because I shouldn't have if it's done proper, then I can help someone out with my gas solder. As we spread out the strands on the wire, then we merge the strands, feed them into each other, and then we twist. And what we're trying to avoid is little strands sticking up and out, because that will potentially poke through the heat shrink we're going to put on afterwards. Now, I don't have a wet sponge with me, so a bit of wet paper towel will do the same job. This is called a hot solder. Right now, I'm getting the heat transferred into the copper because you want the copper to absorb the solder. So you put the soldering iron underneath and then you push the solder through from the top and it'll soak it all up. And there we go. You can see the solder is just being absorbed by the wire now. Don't be too alarmed if the coating becomes discoloured, as you can see on the red wire there. Also, just keep in mind those fumes are very toxic, so don't breathe it in. So while it's still warm, let's loosen this up. While it's still warm, let's get this heat shrink slid over, like so. There we go. And you can heat this with a lighter, or I've got this little device here that puts out a lot of heat. Just want to evenly spread it out. So there you go. Now, obviously you don't want to be using a red and a black wire and join them up. I just did it so you could see the two different wires. Right now, I'm showing you how not to do it. This is called a cold solder. I am melting the solder from the top onto the copper. The copper is not getting enough heat through it to soak up the solder. So this is only an outside coating. This is a weak connection and can cause a possible short later on if it comes apart. You're just going to heat from the bottom. I'm now fixing the cold solder by heating it from underneath and letting the copper absorb the solder and also adding more to it. So you can actually salvage a cold solder if you've done one for whatever reason. This is a great connection and it won't take too long to gain this skill. Just showing you, you can also use a simple cigarette lighter or any kind of lighter. Just don't put the naked flame onto the heat shrink, otherwise it will catch on fire. As I mentioned earlier, a drill and a stepper drill bit. Now the stepper drill bit, I recommend over getting specific size drill bits or hole drillers, because it costs a lot of money. It adds up really quick, because you'll find that your grommets that you're going to use are going to be different sizes. Also, even if you're not using the grommets, you'll still need to drill holes somewhere to feed your wire through. So what is a grommet? Well, these are what you need to feed your wires through into your box or wherever you're putting the wires into. This will keep any water and moisture from coming in and out, which is a good idea. Obviously you want to keep the box sealed and the wires dry. So basically you need to drill holes for these. Now after you drill the hole, highly recommend you get some files and you file the holes out to make it nice and smooth, especially if you're not using a grommet, because then you've got wires onto the edge and you don't want it chafing through and then causing a short. So definitely file it, and if you can, put some rubber or something, maybe a bit of pinch weld or something, just to keep those wires nice and safe. Rightio, my next tip is testing things before you finalise things. So you'll need to learn how to use a multimeter. These are cheap as. Okay, all you need to know how to use is the multimeter on the voltage. V20, that is what you need to use so you can check your battery voltage, or if you've got current through wires, red to positive, black to negative, or earth. Further on to testing things before you put things in. A pair of Light Force lights, 20 watt lights here. They've all been quality tested, I presume, but it's always worth testing the light before you actually go to hook it up. So what I have here is those crocodile crimps I showed you. Now just be mindful that there is no fuse and line here now. We're testing it directly onto the battery terminal or to a 12 volt source to check if the light is working. Now I'm going to show you how to do the thicker wire. So I have stripped it with a pair of pliers because there's no real wire stripper that I have that can do this. Twisted the wire, got the lug, twisted on just like the other ones I showed you before with the crimper, and leave a bit of copper exposed so we can feed the solder in. And we're going to heat this up with a blowtorch. Here we have the big crimper. Now I understand that you're not going to have one of these. You can get a smaller version, but I would suggest getting these wires done by maybe a professional or something to get them done, because they'll have the tools and everything. Because there's no real point in buying the tools and everything, because the same amount of cost, you could have had it done by a professional. And if you stuff these up, these lugs, they add up if you don't get it right. So here we go. I in fact got most of mine done. Like so. I've already got the heat shrink on. I'll put it on beforehand, and in this case leave it back about 200 mil or so it doesn't get any heat transfer. We're going to put a lot of heat into this wire, and this, the first 10 mil of this rubber here may get very discolored and get really soft, but that's okay. Again, ventilated area, and don't breathe this smoke in. Now, ideally you want solar to come out the end there, so you could actually feed it in from that end too. But just a quick demo. Got the heat shrink over. I'm not an auto sparky, and this is how to DIY. So that's good enough for me. Thanks for watching. I hope you picked up some good pointers and tips there, and hints and advice. Now, I have done a general video as well about the general side of modifying or doing electrical work on your overland vehicle, which is really important to watch as well. I think that's more important than this actual video here. I mean, this shows you how to DIY it. The other one will give you some insight on, even if you're only doing bits by yourself, so that you know the best course of action and what you actually need and what you don't actually need. So that link to that video will be down here. So thank you very much for watching. You can subscribe right here, and you can support the creation of content like this at patreon.com/RonnieDale. Thanks for watching.